Hello. This is a problem that's actually from last week's material, but it's a good problem. It'll be helpful for homework too, so we're going over it right now. And you probably don't remember, lecture 3 has a slide that says these two statements are not equivalent. For all x, p of x, or for all x, q of x is not the same thing as for all x, p of x, or q of x. Doesn't work. But it turns out one of these implications is true. One side implies the other, but the other side does not imply back. So one of these rows is true, one is false. And I'm going to talk through how I just thought about this like intuition-y. Didn't prove it or anything like that. We'll learn today how we could prove these formally. But just for our own convincings of ourselves, this is how I thought about it. I thought about the simplest example I could make that would explain these two statements in English. And lecture uses the predicates p of x is x buys an umbrella, and q of x is x buys a raincoat. And I'm going to imagine the domain is this room with two people in it. That's it, nobody else. And so if we start with this statement here, what are the two cases this room could look like, a room with two people, that would have this statement be true? Well, either for all x p of x is true, which would mean for the two little people, they both have umbrellas. Look at their little cute umbrellas. But that's not the only case. We also might have that these two little people both have raincoats. This is the world's ugliest raincoat, but whatever. So both the people have raincoats, or they both have umbrellas. Now, what would this statement translate to in this domain of two people? What are the cases this could be? The for all x, p of x, or q of x means that both people, or everyone in our domain, either has a raincoat or an umbrella. But we don't necessarily have to have it so that they both have the same thing. So we could have that one person has an umbrella and one person has a raincoat. That would be a valid case where this statement would be true. Now, that's not the only case. The room might look like both people have umbrellas. That still fits. That's totally allowed. For all people, then it just happens that they both fall on this side of the or statement. Or they could both have raincoats. Raincoats are hard. So these are what the boxes could look like that would make purple, purple, red, red statements true. And now we gotta figure out what implies what. And I'll just start with the first row. If I tell you this purple situation is true, as in this statement right here is true, then do I know that the statement, the red statement, is true? Well, if the purple statement is true, I'm either in this first box, and if I am, well, that works out. That box is right here. Or I could be in the second box where they both have raincoats, and that also works out. Turns out they both make the red true. Both will be true. So we get true implies true. Now we don't have to care about when the purple statement is false, because false implies anything is true, so that's fine. And true implies true, so check mark. True implies true is true, that's what I meant to say. So absolutely, this statement is true. Fantastic. Now, I said one is true and one is false, so take a wild guess at what the next one's going to end up being. Yes, it will be false, but why? Well, let's see. These three boxes drawn up in red are the three cases where this statement down here would be true. And then the boxes in purple are the two cases where this statement on the right would be true. And two of those work out, right? If we're in the case where they both have umbrellas, that's fine. If we're in the case where they both have raincoats, that's fine. But it's still true if one has an umbrella and one has a raincoat. And then that doesn't work. So that would be an example when this left-hand side is true, but then the right-hand side is false. And that is false. No good, does not imply, can't work out. Just because I promise you that we're in this red situation does not mean I can promise you that we're in this purple situation. So these two statements are not equivalent. Again, we didn't prove this. I picked one specific example and talked myself through it. But we could prove this. So I guess keep watching to learn how.